truly building a general intelligence, we need the AI not only to learn only from our data, right, from our state experience, but it will be very powerful if we can let this AI continuously improve and also refine itself. Right? It will be interesting to see, for example, if you let an AI agent and live inside the world of Genie for example, like months or years. Like, what can it discover, right? Because we already seen this with Voyager, for example, for like NVIDIA. You let an agent play Minecraft and it can like already learn the mechanism of Minecraft. It can learn to survive. It can learn to craft things, be creative. So I think the next wave of AI should not only be like only intelligent, but also like creative, because a lot of like our thought process, our problem solving skills from humans are open-ended. They are like learn from experience continuously, and we try to improve ourselves, right? For example, if we are stuck working on a problem, then we try to augment ourselves with new knowledge, new tools, right? And I think this is the way that we should train our AI like forward, because we need this AI to continuously refine itself. And we've seen those like success stories recently. So I think we're not that far to a future where like open-endedness will be like a key ingredient in enabling like more intelligent systems and hopefully bring us closer to like AGI.
Thank you for joining Once Changing the World. I'm your host, Eddie Evelyn. Today I'm delighted on to have with me Mr. Richard Swandi, who is a PhD student at the Chinese University of Hong Kong, Shenzhen, and a research intern at Huawei. He is interested in building open ended intelligent systems capable of continuous learning, efficient knowledge acquisition from limited data, and generalization across an evolving range of tasks. He is also the author of the blog Posterior Update. So, Richard, really appreciate you taking time and being part of the podcast. Want to start with large language models versus world models, so there are a lot of people, I think, in my audience, who kind of understand what a large language models are, these foundation models which are trained on humongous corpus of not just text but also image, videos and code, and it's able to predict the next word tokens and create these text to image, text to video, text to games, and so on and so forth. Not many understand what a world model is. Will be great if you could, maybe uh, explain what a world model is, and what can it do at this point of time.
Yeah, perfect. First of all, yeah, thank you, Eddie, for inviting me to this. I'm happy to do this podcast. And yeah, maybe let's start with some basics about LLMs and also what are the differences between LLMs and also word models. So maybe most of the audience here are familiar with like large language models. So like the name, they are basically language models. So they are mainly used for text generation, although we have seen many variants. For example, today LLM can do more than just text generation. It can also generate image. It can also generate code. So many of those modalities can be inputted into this LLM as well. However, in the basic working of an LLM, they're just basically a next token prediction. So no matter if you want to generate code or generate text, generate a story. Basically, it takes all of the prior information or the context up to that point, and then it tries to generate what's the most probable continuation for that text or for that code, right? So inherently, it only like a probabilistic model. So it takes all the possible combinations or maybe the possible choices for the word, choices for the code, and it outputs that in the next step, right? However, it lacks some of the like the physical understanding, or basically, our world is much more complex, right? We have many causal effects, many physical properties in our world, and this is where the word model comes in. So the main idea or the main premise of like word model is that what if we, instead of just using probability distributions, right? What if we can inject some of this physical knowledge or even this causal knowledge into these kind of AI models. And this is precisely what word models are trying to do. So they try to simulate our world. So, for example, we live in our daily life. We have a lot of interesting going on in our life. For example, some interesting physics. For example, if we drop a ball, that it will fall because of gravity. and that if we punch a glass, then it will break. So those kind of understanding, uh, we want them not only to memorize them based on the text that they have written. Of course, LLM can do that, right? So if you ask ChatGPT, you can ask it, what happens if I, for example, drop a ball? Then it can answer it. But we're not sure whether it's just memorizing, or because if they already seen it from a textbook or something, or does it really understand the physics, or like why? What if we change the object? What if we change the setting, right? So that's why the word models is try to augment this kind of like physical meaning and also this causal understanding into these AI models.
Thank you for explaining it, simplifying it. Yes, I think large language models. They're known as next token predictors, but I think next token generators. But I believe that they're doing something more than that. And these world models, what's missing with for the LLM was that these LLMs were not grounded in physics, and they didn't have like the spatial understanding of the world. And these world models, the intention is to have the spatial understanding and be grounded in the physics of it. Now, Ilya Sutskever, in an interview with Hansen Wang, he had quoted that LLMs are not just pattern matchers. They're doing something more. They kind of develop their own coherent world models. Can you explain what Ilya meant for my audience, please?
Like you mentioned, like, so Ilya has this like crazy prediction, I think about like 2 years ago, that shocked the world, and many of the people, some believe him, and some don't really buy it. So he mentioned that actually LMs are actually building a world model inside itself, because he argues that, for example, LLMs are trained in, like, for example, the whole internet, right? So it contains almost all the knowledge from our human history. It understands a lot of like our intuition, a lot of our thoughts, a lot of our, for example, the thought process that we have when we see things, right? So Ilya argues that they might have built like an internal or like a latent word knowledge about a word knowledge about everything that he sees around it. So this can be derived from all the text, all the knowledge that it has in the internet. And they mentioned that because of this knowledge is really big, right? And LLM seems to like compress it into like a, because during the training process, it needs to learn, right, how to do some this kind of like next token prediction, right? So somehow Ilya believes that because of the vast data, because of the vast knowledge, it might have like this kind of like uh internal model that they have because of the experience, for example, from the training. So that's what he argues basically.
Very, very interesting, because these LLMs obviously are doing something more, which I think some of the brightest minds in the world are not understanding. Yes, I think it's debatable whether these LLMs are able to generate their own world models. And I think Ilya had also quoted sometimes, when ChatGPT 3 was released, that, these models are slightly conscious. I think these are statistical models, but I think even these statistical models ha- are showing up some emergent properties. Now that again, the emergent properties are debatable, but it's plain to see that, at this point in time, AI itself is a complete black box. And even with effort in interpretability, we still do not completely understand the entire functioning of these AI models. Now, in 2023, early 2023, I had interviewed this fantastic founder. His name was Adnan Yunus, and he's the founder of Opus AI. And he was doing something really, really cool. He was building like a generative AI a stack, where his application was, you put in prompt, and via prompt he was building these worlds, and these worlds were like kind of so that was possibly like maybe the early glimpse of what could be done, through these generative AI, where you kind of put in your text, and the model is able to create these coherent the world, like beautiful world. uh, will be great if you could explain, how do you kind of go about building these world models. What's the primary architecture and the data challenges that's involved in constructing a robust and maybe a generalizable world model?
Yeah, cool. So mainly there's like one interesting paper, and I think one of the most influential paper in the word models field. So it's like a 2018 paper by David Ha and Jürgen Schmidt-Huber. So I think, yeah, they also have a blog. I think you can check it online on like word models. So basically, they argue that to build like a word model, you need like three main components, right? So So basically, the first one is you have the vision. So the V component. Basically, the vision basically is like the eyes of this kind of model. Right? So it takes all the high dimensional observations. So like I mentioned, right, although I give it the example like the eyes, but it doesn't have to be like only an image or only a video. So basically, it can take any high dimensional observations. So you can represent it as a high dimensional vector, right? And it tries to kind of encode this into some sort of like compact and also meaningful representation. So basically, they take this observation with like a lot of information, right? So some of them might be noise, might be a lot of signals, and they try to encode the most important part into like a meaningful representation. And then the second component involves the memory, which is the M component, which tries to kind of like learn the patterns given all the encoded representation, and they try to use these kind of patterns to learn, uh, like to see what kind of emerging patterns there are from this data, and they try to use it to predict the future states. So basically, it's like learning and predicting from like experience. So this is the memory component, and the last one is the controller. So I think this is one of the main difference between just like an LLM and also like this word model, because the word model also has this control component, which they try to use not only the representation from the vision, but also based on the memory, right? So based on the observed state and also the experience, they try to compress those and use it to select some actions. So word models, they can also select some actions in the world. So basically, that's why I think they can perform some grid simulation. If you take some action, for example, I think like recently you can see like with the Genie tree, right? You can also take some actions in the world, make some changes in the world, because they do have some sort of way to manipulate the world, manipulate the simulation to make it more even more like high fidelity. So this kind of way. So these are like the three components, and of course, like time has been evolving. So I think back in like the 2018, they kind of use like for example like a VAE for like the vision and also like an RNN for like the memory, right? But nowadays you can see like with the transformer, with the diffusion models, I think the latest Genie model, they use some sort of like a diffusion transformer to like encode this kind of like the image and also the video, and they also have this kind of like latent action model based on like for example they train it also like using some sort of like RL or like using optimization loop. So of course the training paradigm can change, but I think these are like the three main components that I think most world models should have.
Very, very interesting. And thank you for sharing the information, vision, memory, and controller. And yes, I think Genie model, it was it's such an awesome model, and the things that it does currently is so freaky. I mean, like retaining memory, that little person kind of, painting, and then you kind of look back and you can see that, it's grounded. I mean, that the part which is painted is still anchored over there. So very interesting. And these models, it becomes so very unique that it can predict the possibly the next next space in the world, so it gets superbly interestable, these interactive playable worlds. Now, as for us humans, I mean, we humans can infer, I mean, complex world dynamics, and we don't need, a lot of data, and that's like, I mean, when we are born, uh, yeah, we get limited data, but we are able to like and quickly be able to kind of, understand the surrounding and able to generalize mama, dada, papa, bottle and things like that. But that doesn't seem to be happening, so far, with these models. What techniques you think are being investigated to enable these AI agents to learn robust, I mean, world models with significantly less data?
Yeah, that's a really interesting question. So I think this reminds me, like, because some of the researchers, so some of them like shared, like, for example, we are uh, increasingly like hitting the data wall, right? For example, like you mentioned, no matter like uh, for us humans, we can easily, for example, even like a children, right? Like a 4 year old or 5 year old, they can really learn quickly from like based on their trial and errors, based on the experience. But doesn't seem to be the case. Like with AI models, they are very data hungry. You need lots of data, lots of examples to do it. And yes, you can say that we are having the data bottleneck, right? Because for example, the internet are getting more saturated, and you can see like all these benchmarks are getting like saturated. They are maxed by those kind of AI models. Yet I think not many of the AI models have like a really great breakthrough right recently. So I think this is what like the I think also another paper by Google DeepMind. I think it was like by Richard Sutton and like David Silver. They mentioned that we are soon entering what they call the era of experience. So instead of like relying solely on the data, right? Because data, for example, you soon hit a data wall. Of course, I believe and I'm quite bullish on like some of the idea of like synthetic data augmentation. I think that could help like alleviate this kind of like data issue. However, I'm more interested in this kind of the experience. So basically, Richard Sutton and also David Silver, which are like one of the two of the most like respected researchers in RL, they believe that we need to learn from experience. Let these AI agents to go outside the world. So even like you mentioned, we already have these kind of models that are pretty good in like generating world, generating like realities. So why don't we like deploy them in this kind of models and let them explore? So I think this way is like very effective then, because as you can see, right? Because I think uh with uh, quite well ago, you can see like with like the Alpha Zero and also Alpha Go, learning from experience from like self play is very effective, right? You don't need a lot of like human label data. You don't need a lot of like human supervision, but just letting the AI agent play against itself, play millions of games, you can see that the performance can be dramatically improved. So I believe that with our like AI agents and also word models, we can also have like a way better kind of like performance if we let them learn from the experience. And then uh, at the same time the word models get refined from the feedback from the AI agent, and then the agent can live in like a better world, and then they have some feedback. So this form like a with I think a very positive feedback loop, I think.
Interesting. The point that you mentioned about data bottleneck, I had interviewed Alvin Wong Grayling. He's the CEO of STC. He's an awesome individual, and he thinks otherwise. He thinks that data is not the bottleneck, because his argument on that is, there is so much of private data at this point in time. I mean, I think some of the top companies in the world, small companies, big companies, there is so much of private data which is not made public. So he really believes that, there is the data is possibly not the bottleneck. There is so much data which is maybe we have not able to exploit or use yet. Eventually, if we do, obviously, I mean, I think the models are just gonna go, I mean, become completely fantastic. And to your point about learning from experience and self play, I think that's so very core, and the addition of synthetic data. I think because the world today, like, there is one human created data, and that there's this soon, I mean, which is growing number of synthetic data which is being generated. So I think, I mean, these things, maybe possibly maybe we need to look whether the data is truly a bottleneck, where maybe possibly can we get data from these private companies, and then maybe synthetic data. And I think, the scaling hypothesis is there. And obviously, I mean, there are so many things which is still uh, which I believe that can be exploited. Maybe possibly, like, even like the way we are kind of creating these models, because I think we are the cusp of creating the most fantastic maybe tool in human history. And we are doing what we do best. Like, what we do best is we break things, we divide things. Now just imagine if we were united, and just an example was COVID. When COVID-19 happened, I think we created a vaccine in such a short time, because I think world over all of us kind of joined hands, and just imagine today, I mean, if we had DeepSeek, OpenAI, Anthropic, Grok, Mistral, DeepMind, Meta, all of them combining, I'm sure we could have possibly maybe developed uh, general purpose intelligent machines. But I guess since we are so trapped by our greed, and maybe personal growth, and this whole effort of, like, okay, let's build maybe these machines which are general purpose intelligent, and then eventually if we get that, then we will become the leaders and then we'll rule over the world. That conversation, I think, inherently is wrong. I think we need to change that, where I'm not so very sure whether we humans are evolved to kind of understand whether we can do that, because if we do that, what a fantastic world that we'll get into. Possibly we'll be able to age reverse. We will be able to maybe erase all diseases. But yes, I think maybe those are the fundamental bottlenecks. I mean, I don't think it's just the data bottleneck. Now the real world, that there's a lot of inherent uncertain. I mean, like what I do right now, if I do something, something can happen which is unexpected. So how do these current world models represent reason about these uncertainty, and what are some of the promising avenues for possibly improving the ability to handle these incomplete information of the world?
Yeah, I think that's a really good question. So yeah, so we've seen like with large language models now these days they have this they kind of like reasoning traces, right? For example, we can now see their like reasoning, their chain of thought, right, when they solve a problem. So but I think for like large language model, because they are limited in text, so we can only see them like through text, right? But even for these LMs, they have, I think some of the researchers, I think there are a lot of papers that have talked that what if we let the large language models not only reason in text, and but what if we can use it for like other representation? So I think there's one paper from like Meta. They propose that these LLMs can perform better when we actually do not understand what they're talking about. So kind of like a latent thought. I think there's like the title of the paper, like some of like latent thoughts, or like LLMs think like in the latent space. So this kind of thing. So I think that is also something that could be effective for like our word models, because like you mentioned, there's a lot of like uh, not only the input is only the text, but for word models, there's a lot of like modalities involved, right? The vision and also the memory inside, like I mentioned, right? And also based on the experience, which I think is very limited if we only restrict it into like a text. So if we let these kind of models have this kind of like a latent space where it can, for example, just output what kind of like their uncertainties, what are those kind of things that they are unsure about. Maybe they can also have like some reasoning traces. They have this kind of like inner voice, right? They try to, before they take some action, they kind of like think, right? Oh, they kind of like can imagine, maybe, because word models, they basically they try to simulate realities, right? So I think there's fundamentally no restriction that makes it hard also to like imagine things. For example, we can have like a new term, like not only chain of thought, but what about like imagination, or maybe during the bedtime, these AI models can also dream about some scenarios, right? I think that would be like interesting. Yeah.
Yeah. So, Richard, I think we getting into such an interesting phase. I'm forgetting the name of this researcher I had interviewed. This was a couple of years back. I believe he was from Stanford, and he had created this model which could predict crime in advance. This it was in a very nascent stage, but he had actually also deployed it in United States in a certain city. And that's so very interesting. I mean, with limited data. I mean, not it obviously is unable to generalize, but with the data kind of, I mean, you feed the model with a certain kind of data, and it's able to kind of, I mean, predict that in a certain area, a possible crime could happen. So I think these world models are possibly these effectively, I think, they're simulating these, futures, and like you pointed out, it has these possibly maybe like an inner model or internal thought process of sorts. Can you talk about these current models? Because there are these many world models at this point in time. There's Genie 3, Hunyan, who I think they're building something. Then there is Odyssey. Then there's Descartes, which is I think Israeli company. There's Lucid, and there's others who are kind of building a world model. So it will be great if you can maybe elaborate to my audience, like I mean, the features of a world model, its memory, its understanding of physics, and the applications. What could be the applications of a world model?
Yeah, I think like these days we are so blessed to see like a lot of these advances. It's like word models, and it's very interesting. And for me personally, it's one of like the greatest thing I have ever seen in my life. Like this kind of like AI. like what are tend to be life, like seeing this kind of models simulate realities. So I think, like you mentioned, that there's a lot of like companies building this, and I think some of the prominent examples include like the Genie tree from Google DeepMind, and also the World Labs, I think led by Professor Li Feifei, and also from the Chinese company, we also have the Tencent. They also have this Hunyuan, right? This kind of models. Yeah, yeah, yeah. And I think they're aiming at the same thing. They try to kind of like uh, build the next generation simulators of our world, and these have like a very broad applications, right? And one of the I think one of the most direct and straightforward applications is of course gaming, right? So we know like with games, for many years, we've been relying on like game simulators. But if you have like any experience in like building games, these simulators are very like game engines are very hard to use, right? Because you need to some sort of hard code some of the hard physics, and you need to take care about a lot of aspects, right? For example, the consistency of the characters, and also the lighting, right? The shadow, for example, and not to mention if you have like a very like fictional game, then you have a lot of like mechanisms that you need to code by yourself, right? But with this kind of like word models, like I mentioned, for example, like the Genie tree, we can see that they already has this kind of like interesting emergent properties. They seem to already understand and already has this like physical understanding embedded in their model. So, for example, I think I think you can see some of the examples from the video or from the Genie tree, or even like recently, I think the Word Labs also give some preview about their models. So even starting from like a single image, then it can like infer what is the next pixels, what like what are the next uh, like most probable thing that we should see. And even when we do actions, it can actually be very consistent. Like I think you mentioned previously the painting example, right? I think that's really impressive because then a lot of this hard work that we put, for example, in gaming, right? In like we want to encode this kind of like consistency, we want to encode like the environment, then we can just do some prompting, give some reference image, and then there you go. You have one scene of the game, right? And another example on applications that I think worth mentioning is of course entertainment, right? Because I think I think with the latest hardware technology, even we have the VR technologies. We have this like for example the Vision Pro, right? We have the Meta Quest, right? Then I think soon, right? I think soon we're entering the metaverse, right? Like they propose, right? So well, the entertainment is no longer only like a no longer like a very static experience from like using like let's say watching video, watching movie, but it can be very interactive. For example, you can even step inside the world. You can even wear a headset or wear a VR glasses, then you can actually be part of that world. And I think this kind of web models is one of the great drivers of this kind of like technologies, because now you can basically simulate anything that you want to experience, right? But of course, there's still a lot of things that we need to do to make it immersive. But I think in terms of like the giving like a very realistic experience, I think word models are a really good contender in making that possible.
Right. Yeah. How interesting. So I've been invested in virtual reality since the last 10 years. The entire gaming process, it was like the traditional gaming process. I mean, you have to first maybe like create an idea of what game that you want to create. Then you start with possibly maybe designing, if it's a 2D or a 3D game, you're designing those models. Then you take it to a game engine, like the cutting edge game engines today are like Unity and Unreal. You bring in those game engines, and then you spend so much time to kind of program those movements and interactions and things like that. And it's such a effort, I mean, to create a game. And today we have these uh world models, which is like you put in an image, and that image becomes playable. How cool and how interesting is that, and also very scary, because I believe there's millions, possibly I think, are game creators, and thanks to like Roblox, because I mean kids today I think creating games, because they're fascinated and like you pointed out, virtual reality. I think in the next possibly maybe 10 years, at the rate at which uh, extended reality, the umbrella term for AR, VR, MR, the way it's kind of growing, I think we will be consumed with XR. There will be like agentic AI. We'll go from carrying technology to wearing technology. What I mean by that is, our phones and computers will become one single wearable device, like this, a head wearable device, and the entire world will become a canvas, like a screen. And your computers, your theater screen, and everything, and that's the world that we are getting into, and it's going to be powered by AR, VR, MR. And because of the AI layer, you'll have an ever present AI agent. That agent will do anything and everything that you want to do. It becomes so very interesting if we all come together, and it becomes so very scary if there's like a centralized company which is kind of building that kind of future. uh, do you worry about that kind of a future where the world model kind of grows? Do you have like an idea of what the world could look like, what the future of entertainment could look like, with what could gaming look like, and how much would it disrupt the people who are kind of like actual, I mean, who maybe the bread and butter is like creating games and entertainment. How deeply you think the world is going to get impacted when these world models like evolve and are able to maybe truly do create fantastic playable worlds.
Yeah, I think this is like a very important question, right? Because like I just mentioned about all the benefits. Like for example, it could enable like the next generation of like gaming, the next generation of entertainment. And I think of course it's with all this like kind of like technology breakthroughs, it's always like a double-edged sword, right? You have like the positive side, you also have like the negative side of to it. And of course, like you mentioned that one thing that these models are getting really good at is just you can basically enable everyone to be like a gaming programmer, right? A game programmer, right? Because you can just start with like an idea. You have this kind of like idea. Oh, this is like the game that I want to make, right? And even for the characters, you don't have to draw it by yourself. You can even use this kind of like image generation models to generate the characters, generate all the assets for you, and you just put everything into these word models. You give this kind of like reference story, reference prompt, reference images, and then boom, you have the game, right? So of course, a lot of this process can be automated, which means that then I think for the junior roles, for this kind of like people working in this kind of gaming industry or the entertainment industry, for more of the redundant tasks, more of the like basic coding, I think this could be replaced like pretty soon. I think that's what I think, and this could be like a very scary. So, but I think on the other hand, there's still a lot of opportunities and a lot of doors to be open because while this kind of like low level and also like redundant kind of like hard coding things can be automated, there's still a lot of like creativity, still a lot of like even like advanced mechanics and that could be designed even by like the senior programmers or even the human experts, right? So of course, human are still needed in the loop, but for those who want to sustain in this kind of industry, then they need to upgrade their kind of skills to kind of use this and harness this kind of word models as a tool. And you need to kind of like be this some sort of like the guidance the guide for this kind of like models. So I think that's for like the crazy implications in terms of like the career and also the job prospects. But I think I want to touch a bit on like the another scary thing that I can envision, if you don't mind. So I think with this kind of like AI models, right? So we've seen from, for example, starting with just simple video generation models, for example, like Sora and also VO3. And I think a while ago, the Andres Karpati, like a very well-known AI researcher in this field, he mentioned that he's scared that this kind of like video generation can be detrimental, can has like a very bad effects on like humans. Because, for example, like now we have Instagram, we have like TikTok, right? We already have this algorithm that are really good at keeping our attention, right? So people are getting addicted to these kind of like platforms. And just imagine like this kind of like video generation models now, basically, they are like neural networks, right? They are neural networks. So basically, their outputs are also the outputs from the neural network. So which means that you can optimize them, right? For example, you can optimize for the user engagement. You can optimize from the user profile what kind of videos they like to watch, and then you can generate a brand new video like they never seen before to keep them engaged and stay and stay in the application. And just imagine this with the word models, right? Which much more impressive and immersive experience. Then I think it's very easy for people who are not careful to be like trapped in this kind of like worlds generated by these AI models. And it could be scary, for example, when people are stuck in these simulated worlds and especially when these kind of like work models, they start to generate a very realistic world that is almost indistinguishable from the real world, then they kind of like start to forget about the real world. They can be like the lines between the world and the simulated world can be blurred because they basically can do even more things. For example, later in the AI generated world. So I think this is something that uh, I think the policymakers and also these leaders in the AI companies should also pay attention to. I think.
I think the kids today, they spend more time in the virtual world rather than the physical world. And it's not just the kids. I think it's grown-ups, it's the elder population. I mean, today it's almost like a pandemic of sorts, because you go to, you sit in a train, you sit in a bus, you are at a dinner, with your, family and friends. There's phones. I mean, most of the time, people are hooked onto the phones rather than having this physical conversation. Yes, so I think, there is such an urgent need of the narrative to go out, an urgent narrative, that these digital overload is creating a big problem. And like I said, I'm vested in virtual reality, and I think virtual reality, the name itself, says, I mean, what we're trying to do with virtual reality, we are trying to build a virtual reality which is indistinguishable from your physical reality, because that's the end goal. And I think that's going to happen with a couple of convergent technology stack, because we have these brain computer interfaces, then we have AI, and then we have these XR, these XR headsets also, there's companies like Wario, and then there is OpenBCI. They're building these virtual reality headset with these brain computer interfaces, which is attached, and eventually, I think, I mean, sooner or later, I'm sure we'll get into a world like, which is projected in the series such as Black Mirror, where we will be able to uh, maybe enter these virtual worlds, but those virtual worlds will seemingly feel real, because we'll have all our senses which will be triggered, because what do we have? We've got five senses: sight, sound, touch, smell, and taste. With virtual reality, we are able to emulate sight and sound beautifully well. What remains is touch, smell, and taste. And I think with brain computer interface, those are things, because the way we have these human connectomics project, we are kind of trying to map the structural and functional capabilities of brain. Eventually we'll be able to map the entire brain. And once we have that, and with AI, with these world models, you create these simulated realities, and you are in those worlds. And it's an eventuality. It's not like, okay, this is something which is improbable. This is, I believe, it's an eventuality. And I hope that there's more conversations going on with schools, with colleges, with businesses, with the governments, that we are crossing the point where we are losing human connects. We know so many social friends of Facebook and our TikToks. We have hundreds and thousands of friends, when in a physical world, we are grappling with depression. We hardly go out, we hardly meet. So I hope that we look into that. And you also pointed out, with this AI automation, and these models which are scaling so fast, we need to have conversation. The governments need to take onus and say that these models are becoming more and more capable, and eventually these models will be able to code, will be able to be your co-scientist, will be able to be your co-creators. Then what are the jobs which are left for humans? There is that other side, that okay, this AI is democratizing things, that today, even if you are not a coder, you are not an engineer, you get to participate. So that is beautiful. But unless and until we don't kind of uh, maybe have conversations where we create awareness about this world, I believe that we are going into a world. It's like the Pied Piper. It's leading us the entire generation to nowhere. Now you spoke about synthetic data. Now the synthetic data, I think, is like a big thing, because these models can be trained in these simulations, once these models are being trained in these simulations, they understand the physical world, and they are able to generalize better. Can you maybe elaborate on these world models, these capabilities of simulating these virtual worlds, and how would these AI agents be able to be trained on them, and maybe how would that training help them into maybe becoming maybe maybe more generalized?
Yeah, basically, I think this first concept of like learning from like simulation, learning from this kind of like in the simulated world, also came from the paper that I mentioned by the David High and also Jürgen Huber. So I think they mentioned it like to learn inside dreams, right? Basically, so basically, like the AI agents, they are deployed in this kind of like worlds, and they try to observe the environment. They try to learn the dynamics of this kind of environment, and then they also is able to do some actions right in this kind of like simulation, because I mentioned they also have this kind of like controller component, so they can kind of like try things. For example, they can try, for example, like, oh, what if I open this door, what if I choose to walk in this path in the, or what if I choose to like walk up the stairs, right? Those kind of things. And and then these kind of models, for example, since we generate the words for these models to be trained to learn, so we can also employ some of like the training policy like reinforcement learning, like RL. So they taking some actions or performing some actions in the world have some like rewards, right? For example, like I just take an example that we already talked about. For example, in the painting example, right? For example, when you do the painting, right? Of course, the action that yields high reward is that when you do this kind of like stroking, then you leave a mark on the wall, right? Then that is the high reward, right? For example, and then for example, if I turn to the left and then I try to look it again, then the painting or the paint should be there, right, in the wall, right? So those kind of signals we can try to encode it uh, as a reward, similar to like how we train AI agents like for reinforcement learning, and then basically this policy is like memorized and also learn through experience by this AI model, so that when they try to do the next action, or even in the new world, they kind of like still remembers those actions that yields like great rewards in this kind of like scenarios. So I think that's how like they kind of move, right? Kind of like learn and move quickly, and they try to tackle like new tasks. Yeah.
Interesting. Richard, now Dr. Fei Fei Li, she was one of the pioneers of computer vision, and she's the one who believes that world models are a pathway to AGI. What are your thoughts on that?
Yeah, I think that's very interesting because like some of these AI leaders, for example, like Dr. Fei Fei Li and also I think Yan LeCun, right? They believe that unfortunately, despite like the impressive like capabilities of LLMs today, the LLMs itself like in this kind of version would not take us like to the AGI. We need something more, right? For example, and I think like in an interview, Dr. Fei Fei Li mentioned that uh, because we live like in a 3D world, right, where the nature that we see out there, like actually there's no much language in there, right? There's not much text, for example, in like the trees, or even like in the environments that we see every day, right? So we need much more like modalities. We need much more training procedure that we can use, not only learning to like predict the next token, but we need something more, something to be encoded, right? For example, and I think word models is taking a step to the right direction, because somehow now we have models that understand the physics, like I mentioned previously, and also this kind of like causal effects. For example, if you do certain actions, what are the consequences? I think these are like important ingredients toward the work models, right? But I think towards the AGI, towards something that is really general, something that really, for example, is very universal, then we need to generate lots of worlds, right? And then the question here remains, right? For example, just like with LLMs, we have this kind of like data issue. What about the world issue, right? Then, but then this becomes like a more philosophical question, right? So then, how much more we can imagine, like because now for these word models, it seems that it is now limited by our imagination, right? Like we can prompt them to generate this kind of worlds, but we it's impossible for us to like enumerate all the possible scenarios, right? So I think the next evolution is that we need a smart way to kind of like generate like important simulations, especially those that really yield good results on this kind of like uh, generalization performance. And I'll be interesting to see that in the coming years. Yeah.
Right, right. Interesting. Richard, I mean, these world models, obviously, they seem to be grounded in physics. They've got memory. They're doing some interesting things. Largely these are vision models. Uh, what kind of data you think, if you add, it might maybe be able to generalize better? Would it be like some haptic feedback, these proprioceptive information, auditory information? What are the other modalities you think, maybe we need to fuse into these world models to be completely grounded, where it understands or complete the world model and is able to generalize?
Yeah, I think that's a very interesting question because, like you mentioned, now these word models, like the even the vision component, right? They only limited to this kind of like the vision, right? Because they basically now they can only take this kind of like images. They can only take like videos, right? Because I think for like models like Genie, they are only trained on like video games, right? Those kind of things. But I think like you mentioned, incorporating more modalities can be a very important way to make this kind of like word models more general and also like more holistic kind of like intelligence, right? For example, I can think of like you mentioned, touch and haptics is very important because as humans, right, we rely heavily on our like sensory, if especially like touch, right? When we do certain actions, right, then there's a lot of information that currently they don't have. For example, what about the texture? What about like for example the temperature, right? Imagine like these AI agents can now touch something and it can understand like, oh, this is something that is cold, something that is hot, or even it can touch like the trees and understand, oh, this kind of like surface is rough, this kind of surface is soft. Those kind of like information I think is missing in our kind of like word models because vision is very limited, right? You cannot see something like that is hot or cold like purely from like vision. It's hard to do so, right? Of course you can with some smoke, but what if for other things, right? So I think like touch and also like this kind of like and also other things, for example, like audio, right? We've seen like with like VO3, it can also generate audio. So I think the next step for like, for example, like word models, I think it could be pretty soon because we've seen it work with like video models. So I don't see it like be like a very, very hard thing to overcome for like word models. So imagine you can also work inside like a walk inside the world generated by these kind of models. And you can also have the sound generated for you. For example, when you walk on a grass, then you have this kind of like the grass sound. I think that will be interesting and like and it definitely will make it more immersive. For example, if you integrate it into this kind of like XR and VR technologies, I think.
Now, there's this other conversation of, I mean, world models, and which is also linked to, like the simulation hypothesis. I mean, that, what's the point, where these AI generated simulation becomes indistinguishable from reality, and what implication would that have to the simulation hypothesis? Because uh, uh, yeah, what would that mean? What would that mean for simulation hypothesis? That do we actually live in a simulated universe already? Would love to hear your thoughts on that.
Yeah, that's a very interesting question. So I think this is more like more philosophical, but I think I've read like one of the most interesting book actually on this. I think it's by Nick Bostrom on like the simulation argument or the simulation hypothesis. I think he's one of the like the experts or the philosopher that is very bullish on this idea of like what if we are living in a simulation, right? And I think for my own take is that right now it's still hard to see, right? Because these word models are still far from what we expect from like a very realistic like simulation generators. But if someday we can build a world models inside these machines, right? For example, if one day we can successfully achieve this kind of our ultimate goal, right? We can build world inside machines, then what stops us, like for example, like the universe being like one of these like simulators, right? Because the universe, like you can argue, it has like a rich data, rich experience, like billions of evolution. You've seen a lot of like humans, like like us, and also our ancestors, right? And also it also seen the worlds evolve in a very great way. So I think this is like a very interesting philosophical question, and it depends, right? If we can reach this, that I think it's hard to disprove his argument. Yeah.
Right. Yeah. Very, very interesting, because it's not just Nick Bostrom, it's Elon Musk who's been screaming at the top of the lung that, we live in a simulated world. Then there's Clee Irwin, and then there's Donald Hoffman, who's been talking about that the entire space and time itself is nothing but a virtual reality headset. And even quantum physics, I mean, if you kind of dig deep down, I mean, that there's the double slit experiment which says that, or the Copenhagen interpretation of quantum mechanics, it says that the conscious observer is manifesting the reality. So there is so many like loose ends over there. If you kind of like maybe all link it together, then you kind of like you think about it, like, I mean, okay, what I mean, are we actually living in a physical world, or this entire thing is basically like a virtual construct? Because eventually, if we can maybe simulate a physical world, because and we are getting closer to that, we are maybe not now, maybe, but I think there's nothing which is physically stopping us from able to maybe construct a virtual reality which would be indistinguishable from a physical reality. And that, I believe, like I said, maybe earlier in the during the course of the conversation, I think that needs maybe like virtual reality, AI, and brain computer interface. I think when all of these three converges, I think we'll be able to build these extremely coherent virtual worlds with all of five senses, sight, sound, touch, smell, and taste. And once we have those worlds with all of the senses, then I mean, if we can create it, then what is it to say that we are not actually already living in a virtual world? Now you've written this fantastic blog article that AI that can improve itself. Will be great if you can talk about that. I mean, how close or far are we from a system that can self learn and improve itself?
Yeah. Thank you for bringing this up. So yeah, lately I've been like very interested in this topic of this kind of like open-endedness, open-ended learning, because I think it's the way forward. Because I think for like a truly building a general intelligence, we need the AI, like I mentioned previously, not only to learn only from our data, right, from our static experience, but it will be very powerful if we can let this AI continuously improve and also refine itself, right? So, and how far are we? I think to be honest, like with the recent works, for example, with the Darwin Godel machine, right? I think by Sakana AI and also some other group for UBC, right? And they really showed that this kind of models, for example, if we combine the powers of not only like the agent itself, but we augment that, we give them the freedom to, for example, improve itself by augmenting new tools. It can, for example, tune its like hyperparameters. Then this AI can really perform great uh, on like this kind of hard benchmarks that previously when we just let it train by ourselves, it's very static, right? And I think this also like how I think the human evolution works, because if you imagine this, like our nature, our universe, right, we've come a long way, for example, to this form that, for example, now me and you are sitting in this kind of like a podcast, right? We have this kind of abilities, we have this kind of thought process, we have this kind of knowledge. Even our like our physical properties have been like enhanced to because of this kind of evolution. And I think it will be interesting if we let these AI models not only train for a while, but it will be interesting for us to see like what if we let this kind of like uh agents or even the word models to continuously simulate the world for a very long period. And I think there's a recent interview, I think, by the authors of like the Genie 3, I think by the Jack Parker Holder. I think he also mentioned this idea, right? He mentioned that it will be interesting to see, for example, if you let an AI agent and live inside the world of Genie for example, like months or years, like what can it discover, right? Because we already seen this with Voyager, for example, for like NVIDIA. You let an agent play Minecraft and it can like already learn the mechanism of Minecraft. It can learn to survive. It can learn to craft things, be creative. So I think the next wave of AI should not only be like only intelligent, but also like creative, because a lot of like our thought process, our problem solving skills from humans are open ended. They are like learn from experience continuously, and we try to improve ourselves, right? For example, if we are stuck working on a problem, then we try to augment ourselves with new knowledge, new tools, right? And I think this is the way that we should train our AI like forward, because we need this AI to continuously refine itself. And we've seen those like success stories recently. So I think we're not that far to a future where like open-endedness will be like a key ingredient in enabling more, like more intelligent systems, and hopefully bring us closer to like AGI.
What a world it'll be if we build AGI, which maybe serves humans, I mean us, rather than, yeah, I mean, like these various problems that exist. Richard, my last question to you. Um, will be great if you could give some, maybe some advice on, what the listeners, should do, and what should be aware of, in the next uh, couple of years to, be, maybe create their preferred future. What should they do? Maybe some advice on that, and paint a picture of the world that you see in the next 5 to 10 years from your perspective, because you've been invested in AI. How do you think the world is going to change in the next five to 10 years? How's it going to look?
Yeah, I think just gonna say it once again. I think we live like a very beautiful era of our lives, our universe itself, because like what we are witnessing currently and also what we're expecting in the future is very exciting, at least for me. Because of like these like AI agents, we talk about these word models, we talk about this like open-ended AI, self-improving AI. I think they will build us closer and closer to a future where we humans will be like a partner. We will be like an evolving partner with this kind of like AI. So AI is no longer like only like our tools, right? Not only for our tools, but they can really be our partner. So what I see is that, for example, imagine for us like scientists, researchers, then AI can be our co-scientist, right? We've seen this with the Alpha Evolve. They can actually really make breakthroughs, really solve hard problems in our science and engineering kind of field. They can even help us to generate even new kind of like drugs, for example, with the like the AlphaFold, right? New kind of like proteins, to kind of thing. So I think science will be dramatically accelerated by this kind of like these AI models. And for us humans and for the audience watching this, I think that would be great if we could also not only use this kind of AI tools, but we need to learn how to harness like that potential maximally to boost our own productivity, right? So don't focus on like this redundant task, because it's gonna get like automated easily, but rather we need to be like kind of like a creative partner for this AI to guide them, right? Because I think one of the most important features and one of the most important strength of humans is that we are uh very creative, right? And we can see things like even this AI haven't seen before. So I think this will unlock like a very exciting future. Imagine we have like not only AI scientists, right, but also AI artists, right? We've seen this AI generating new art, new music, right? We also maybe in the future we have like AI teachers, right, for like schools, right, for our education, right? Because then, and I think this is where we should play, because now we live in like a great era, and this reminds me a lot like with the like in the history, right? We I think in the history we have the Renaissance era, right? When like this great progress not only happens because of like the smart individuals, but because of the ideas and also the globalization mixing together, right? So then this means that now we should not focus on our own fields, right? For example, artists should also learn can also learn from science, and scientists can also borrow some ideas from like art, right? And I think open-ended AI and also this kind of word models could spark like this kind of new renaissance, right? So imagine like the AI can build lots of interesting things, cross-disciplinary, cross fields, right? So I think the lines of our field, the lines of our like jobs, our own expertise might also blur, but in an exciting ways, right? So AI can help us like give a new perspective, not only from our own field, but also from other fields. And it can also create things that, at least for me, that we can barely imagine today. So I think it's very exciting, and I think this is like a very beautiful moment, like to be alive and also experience all this.
Rishabh, thank you so much for taking time and being part of the podcast. Yes, I think we're living in such a beautiful moment in time, a time where we truly can create magic, and a time where we can truly can create disasters too if we don't collaborate. Because today I think the world is more divided rather than united. I hope that you, me, like India, China, or US, or other countries, or Pakistan, any of the countries, I hope that we come together, we push away the differences and unite. Because I think today we are the cusp of creating a tool, a technology which is self-learning, and maybe we're giving humanity is giving birth to a subspecies of sorts. It's like birthing our own child, but the child this time around could be possibly 100 times more maybe capable or intelligent than us, the creators of it. We need to understand that we are the creators, and we need to give it the right ethos. And like you also pointed out, I think we're living in a fantastic point in time. We need to take these tools and accept them and not be fearful of them. Maybe learn with them, help it augment us, in ways where we can grow and maybe truly understand our potential of who we are and why are we here and what we are supposed to do. And I think we're living in such a fantastic point of time. These questions, if we ask and if we join together, I think we're building such a fantastic future. I'm so excited for the future that can create abundance for all. Thank you once again for taking time and being part of the podcast and sharing us about this beautiful possibility of this world model that we have kind of just laid the foundation of, you know. And what if this world model is able to grow and create these beautiful simulation of futures where we possibly, even if we are in a simulation, what if it creates beautiful worlds where we can cohabitate and build better worlds. So thank you for taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Bye bye. Thank you, Richard. Really appreciate this. Thank you.
Thank you so much.